In this demo, we're going to be showing the various features and functions of the tool called Praeda-II. We're going to start off by just running the Python script to start with. That'll actually show the syntax of the actual device. In this, we have three core syntax functions. We have the ability to take GNMap as a input file. This is output from Nmap, and parse that for web interfaces, which it uses to target during this initial scan and enumeration of devices. We can also take a target list, a list of IP addresses. We can also take a CIDR. First one we're actually going to demo is the GNMap one. We're going to start off with doing the GNMap output. So let's go ahead and kick this off. We're going to be walking through this. And the way this works is the -G will point to a GNMap file. In this case, it's called results. The -J will actually create a folder on our system called demo test in this case, and it'll actually store all the captured data and information. During this process, it'll also generate a log. That log will be called output1. This contains all the core information it was able to enumerate. So let's go ahead and kick this off and see how it goes. So it starts off, we get the IP address, the port, and then we have delimited fields, colon delimited phase. The area it says NA happens to be SNMP data, so it gathers SNMP data. It also gathers server type and header type. Here we end up with a server type right here. No header types in this particular one. And then as we get to certain devices that we've identified to enumerate further, we've written modules to do that. So we have modules that look for certain things on Konicas, look for certain things on Xerox. It'll look for certain data on Ricos, some Ricos, and it'll also look for certain data on Brother printers. Now, all the devices that you potentially identify or gather information, we don't have modules for those. But as we encounter those devices, we'll build modules for them and add that into the actual tool. So we kind of finished running. The initial screen, this is just a general output screen from the actual script. So we get everything that's going on. You may see errors on the screen. Here's an SSL error. It's not uncommon to see those. If the device times out, the port's busy, you'll get the errors and it'll continue on for the most part. But you can see we're actually able to test for default creds on the Konica. We check to see if LDAP is enabled. In this case, the LDAP username happens to be MFP server services, and the server auth type is user auth, user logon. The authentication method is simple, which is basically clear text. We also check for things in the address books like SMB scan, FTP scan. These are functions where the scan bed can be used to actually output data to a Windows server or output to an FTP holding spot. We want to identify those because those configurations could potentially be targeted if the device isn't properly secured. As in default passwords, now I can actually gain access to other things on the device that could be more critical, including LDAP. But you can see we did the same thing down here with the Xerox. Xerox here in this case looks for the serial number as a password, but also checks for 1111, which is common also. This case, we found out the Xerox address books are configured on the device. So that's easy enough. We can do it unauthenticated or whatever. We can just pull the address books down. We can see that unauthenticated remote control is enabled. The remote control function is a capability on Xerox, and it exists on other printers too, or at least the newer models. So you can actually do stuff that you would do typically standing in front of the keyboard or on the in front of the printer itself, but do it remotely through the web interface. Typically, you cannot get access to that stuff unless you are authenticated. In this case, we test to see if it's allowed to get access to unauthenticated. Somebody had to enable this. This creates an elevated risk on the device, and these are the things we want to look for. So let's go ahead and move on. Let's jump over into the demo folder, test folder that we wrote this data out into. So in this particular case, we have a bunch of output files. We had mentioned the address books. So here we're actually able to capture the address books from the Xerox device. You can get the general idea of what kind of information may be contained in that address books. We can also look at the core output file. And here we tag these things. Identified means that we've identified with a fingerprint. Currently, the newest release of Praeda-II has over 800, almost 840, I believe, somewhere around there, of actual fingerprints that it'll actually fingerprint devices. We have modules for Konica Biz Hubs. We have modules for Xerox VersaLinks, at least all the 7000 series. And we have modules for some of the Ricoh devices and also for Brother printers. Way more devices we need to add to this, and we will get to those as we encounter those devices there. But see, we're able to capture this information. Some of the things that may be interesting also is if you're running GMap, this is actually the parse data coming out of the GMap file that actually is created. And if you're running the GMap file and this happens to hang, we have the ability to resume. And what it'll do is it'll compare the output file to this file and figure out basically where it hung at. And it gives you the ability to restart it. And that's done with the rtrue flag. It gives us the ability to do that. If you know there's some kind of hang spot or issue with certain ports, because we found out certain ports get tagged as web ports and they can be problematic in your environment. You can list those ports here during the GMap run and just ignore those ports. And next one I want to look at is this one here, output one. This is all of the general information that is actually gathered. This can be useful because besides identifying where we are able to identify in the standard output log, all the critical stuff, things that did not have any fingerprint could be in here. And this gives you the ability to potentially, if you're able to identify some of these devices, be able to actually build further fingerprints because the SNMP data over here can easily be turned into an actual fingerprint fairly easy. And we'll discuss that in another video. So the next thing we want to do is we're going to go ahead and do a CIDR run, and we'll do that against the subnet one in this particular case, just so we can see how that actually works. So let's clear this out. Come back here, and here we are. So if we come over here and go Praeda, and we go CIDR-in, we're just going to do the whole subnet. We're going to see how fast this actually takes. We're just going to do a single port. We're going to do port 80. Project is demo test, and then -L will go output 1 or 2 is what we'll call it, so we don't step on top of it. And I think we should have that correct right there. CIDR, port, job, logs. And let's go ahead and kick it off. And we'll let this run, but we will also stop it early or cut it out of the video so you don't have to watch it. Okay, we finished actually running that. And if we go ahead and clear the screen, so I wanted to halt it. And we can see we've output log 2, output2.log, and we can see the output we got here. So again, we see that we can do that method, but in this case, you can see we only got results for port 80 because that's what we were targeting. So fairly straightforward, fairly simple use of this tool. Now, some of the other things we're going to cover in another video. We're going to talk a little more about the structure of the tool. We're going to cover the fingerprints, which are under the data section, and we'll talk about jobs and generally how you as a user could actually do further testing and take existing jobs that already are available that have not been tested against certain printers and be able to test those. And we'll show you in a later video on how to actually do that. And that concludes this video.